What's up, party people? This is Dana Harris with Young Gurus Math Tutoring, and I'm here to drop another math jewel. So it's been a long time. I know y'all haven't seen me in a while. Shout out to everybody that's joining in live or if you're watching the replay. Shout out to the students, my 5th grade students that I was teaching the other day at Devonshire. Y'all are great. I showed you all my YouTube channel. And this video is dedicated to y'all. This video is dedicated to my niece that reached out to me and wanted this video done. And so I said, you know what? I haven't gone live in a minute. Let's go live. So let's get it. Today we're going to talk about multiplying decimals. Now, this is specifically this is elementary level, but don't get it twisted. If you are in middle school, high school, whatever grade you're in, or if you're grown and you want to learn how to multiply decimals today, I'm going to show you some basics. Now, I'm going to incorporate some Common Core stuff, and I'm going to incorporate those kind of strategies as well as standard algorithms. So if you need to fast forward when you're watching the replay, then by all means, you can figure out which part you need to use. So I want to share my screen, and I want to start by just showing you all what a decimal looks like on a grid. So here we have a hundreds grid. If you take the time and count these squares, right, there is 100 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 in each column, and then there's 10 columns. So we have 100 total squares on this grid. So when I think about that, a decimal 1/10 of this grid looks like this. Let's go red. So 1/10, if I want to model the decimal 1/10, it would be 10 of these squares, because 1/10 out of 100 is 10. So this would actually be 0.1, 1/10, right? Now I can do the same thing for, so this would be, let's say if I have, let's erase that for a second. So let's say if I have the decimal 3/10, right? If I want to model the decimal 3/10, then 3/10 would be the same thing, but I would just do 3 columns. So going here, that's 1/10, that's 2/10, and then that would be 3/10, right? So this is how a decimal would look on a hundreds grid, right? Same thing. So every 10 squares is 1/10 because it's a fraction of 100, right? So when I look at, let's start very, very simple, right? So let's go with looking at multiplying decimals. Let's say if we have, let's go with some friendly numbers, right? So let's say if we have 4/10, right? Let's go with red, 4/10. And I want to write the problem first. If I want to have 4/10, so 0.4, and I want to multiply that, let's say 3 times 4/10, right? So what that says is I have 3 groups and each group is 4/10. Or I could write this the other way, 4/10 times 3. So I have 4/10 and I have 3 groups of that. So let's do this in color. Let's do 4/10. So that means I'm going to have 1/10, 2/10, 3/10, and I have 4/10, right? I would love to color these in nice and pretty, but I can't do that, right? And so actually, you know what? Let's do this on a different grid. Let's do it on a smaller grid because I realize I'm not going to have enough space on this one. So that's my first mistake of the day, but it's okay. Mistakes are your friend. That means you're practicing and you're getting better. So let's scroll this down a little bit, right? Let's take off the annotate. And I won't be before you too long. At least I don't think so. But this is a lesson you can kind of break down and watch different parts. So let's say if I have 4/10 and I want to multiply that by 3. Okay, so let's rewrite the equation. All right, so I have 3 times 4/10, right? Or we can say 4/10 times 3. For those of y'all that know me, I might say tree. So if you hear me say tree or 3, it's the same thing. So let's write 4/10, right? So 4/10 looks like this. So 1/10, 2/10, 3/10, 4/10, right? And now let's do them in different colors, right? So I'm gonna do another 4/10. Here, and I'm doing them in different colors for a reason. So that's 4/10, and then let's do another 4/10. Let's do this one in, let's go green. So 1/10, 2/10, 3/10. Now notice we've gone over to the second grid, and 4/10, right? So when I look at this, here we have 4/10 here. I have 4/10 here because remember, multiplication is repeated addition, and then together this equals 4/10. Well, I know this entire hundreds grid right here represents one whole. So that's one whole, or just the number one. And then I have 2/10 here because remember we said previously one full column of 10 cubes is going to be 1/10. So I have 0.2. Okay, so I have, and let's make, instead of writing one whole, since we're not working with fractions, let's do it like this. Let's write a decimal. So 1.0. Well, if I take 1.0 and I add, let's do it over here, 1.0 and I add 0.2, then I'm going to get 0 plus 2 is 2, 1 plus 0 is 1, and I keep those decimals. You must line up those decimals like buttons on a shirt, right? So what that tells me is 3 times 4/10 is going to give me 1 and 2/10. Now, we can work this same problem using the standard algorithm, right? So if we work it using the standard algorithm, let's look at it over here. I want to combine the standard algorithm with the visual representation so we can kind of target different levels of learning, right? So let's go over here. Let's say if we have 4/10, so 4/10 times, and I want to multiply that by 3. I think that was our original equation. Yep. So here, if we do the standard algorithm, we start by saying 3 times 4, which gives me 12, right? Remember, in my ones place, I have a 2. I want to put this, regroup this 1, because that's 1/10. 12 is 10 and 2, right? So I'm going to put this 1 over here. 3 times 0 is 0, but if I add 1 to that, I get 1. Now, I'm going to place my decimal. When I look at my two factors, I have 1 digit to the right of the decimal. That's the only digit to the right of the decimal. So when I look at my product, I should have 1 digit to the right of the decimal. Anytime you're multiplying decimals, however many digits that are to the right of your decimal in your factors, the numbers that you're multiplying, that's how many digits should be to the right of your decimal in your product. Now, for 5th grade specifically, you shouldn't have any products greater than maybe to the hundredths place, because that's pretty much as far as they go. So you might see a 10th decimal times a 10th decimal, or you might see a 100th decimal times a whole number, but that's typically what you'll see. You may see one that's to the thousandths place, but we can do an example like that as well. But that's the first example. So that's example 1. Let's write that there. Okay. Hopefully that makes sense to you. Let's do another one to where we use it on the grid first, and then we will show you the standard algorithm as well. If you're joining this late or you're watching a replay, definitely thank you. Do me a favor, like, share, and subscribe. I didn't say that at the beginning. I should have been saying that at the beginning. Like, share, and subscribe, please. I appreciate everyone that is doing that for me. So when I look at this one, let's say if I have 5 times 3/10, right? So 5 times 3/10. I do not like writing my problems horizontally, but I can also, so I usually change them to vertically. So if I have 3/10 times 5, remember the commutative property tells me that the order that I multiply numbers does not matter. I will still get the same product. So what does 3/10 look like? Well, let's see. 3/10 looks like this. This is 1/10. This is 2/10. And this is 3/10, right? So that's 3/10, and I want to do 5 of those. It's going to be going for a while. So let's say, let's go to blue. 3/10 again. So that's 1/10, 2/10, 3/10. Let's go to another color, purple. 1/10, 2/10, 3/10. We got another color because we got to do 5 of these. Let's go pink. 1/10. Notice we are getting to the 1 hole, and my phone is ringing, so I'm going to mute that for a second. 2/10, 3/10. So 1, 2, 3, 4. We need one more. Let's do one more color. 1/10, 2/10. 3/10, right? All right, so I have, notice I have 3/10 here, 3/10 here, 3/10 here, 3/10 here, and 3/10 here, right? Think about this. Remember, multiplication is repeated addition, so I can really do that right there too. Boom. I'm adding all of these 3/10. Well, if we count all of them, we know this first hundreds block is 1. And then I have 1, 2, 3. So that's 1 and 0/10. So 1, 2, 3, 4, 5/10, right? So we write that as 0.5, 0.5. So if I take 1 and 0/10 and add 5/10 to that, so 1 and 0/10 plus, let's say 0 and 5/10, then 0 plus 5 is 5. 1 plus 0 is 1. I line up my decimals like the buttons on a shirt. So 5 times 3/10 is 1 and 5/10. Now, let me throw my little bag of tricks in there, right? I'm not a big fan of tricks, but I know every student and every teacher likes to show their kids, their young people, how to like throw a trick in there every now and then. Think about this. If I have 5 times 3, right, it gives me 15, right? That's a bad color. Let's do a lighter color. 5 times 3 is 15, right? And then there's 1 digit to the right of the decimal in my factors. So I should put 1 digit to the right of the decimal in my factors. So that's 1.5. So when you have some of these simpler whole numbers times a decimal, you simply can take that whole number, multiply it by whatever that decimal is, and then make sure that when you put a decimal to where there are that many digits to the right of the decimal. I'll give you an example. Let's say if I have 4 times, let's do 4/10, right? Well, 4 times 4 is 16, right? But there's 1 digit to the right of the decimal. So 4 times 4/10 is 1 and 6/10, right? I don't want to do the drawing of that one, but I want you all to see that, okay? So we can do this with larger numbers and things like that, but let's step it up a little bit. So let's go a little higher level. Hopefully this is making some sense, and hopefully this is useful to someone out there in the metaverse. All right, so let's go a little further. Let's say we have, I'm going to go to a different screen. Let's say we have, share my whiteboard. Let's say we have something like this, and these are going to be a little more higher level problems, right? So let's say we increase the digits, right? Let's say we have 5/10 times 5/10. Now these I'm going to do the standard algorithm on, right? So this is example 1. Let's say we do the standard algorithm on here. So notice we start from the right. Whenever you are multiplying decimals, you don't have to line up the decimals, okay? Once again, if you're multiplying the decimals, you do not have to line them up. So we'll start here. 5 times 5 is 25. With 25, there's a 5 in the ones place, so we put that there. But there's a 2 in the, or I'm sorry, that's not the ones place. That's technically the tenths place, all right? But we would multiply this as if there were no decimal. So let me show you this. Let's just say we were multiplying this as if it was like this. So 5 times 5 is 25. We carry that to 5 times 0, 0 plus 2. Boom. We don't have to go through because 0 times 5 and 0 times 0 are both 0. But notice there are 2 digits. If we go back to this original problem, there's 1, 2. So there's 2 different digits to the right of the decimal place. Okay. Let's do it like this. So there's a 5 there that's to the right of the decimal place, and there's a 5 there. So that means I need to have 2 digits to the right of the decimal place in my product. So boom. All right. And then now I can put my 0 in the front. So same thing here. I can say boom. I probably should write that larger. So 2. So 0 and 25 hundredths is the product of 5 tenths and 5 tenths. All right. Let's do another one. Let's say I want to have, let's up the ante. Let's say if I have, let's say if I have 78 hundredths, so 0, 78 hundredths, and I want to multiply that by 38. Remember, it's just as if we were multiplying 78 times 38 if we're using the standard algorithm, okay? So we're going to do the same thing, same process. However, we're going to add some decimal places. Now, automatically, we know there should be 2 digits to the right of the decimal place, okay? So in our product, we should have 2 digits to the right of the decimal place. So let's go over here and do it on this side. 8 times 8 is 64. So I'm going to put my 4 here because that's the ones place. Put my 6 here like that. 8 times 7 is 56. And then I have to add 6. So 56 plus 6 is 62. Do that just like we're multiplying using the standard algorithm for multi-digit numbers. I have to keep that placeholder there because technically, remember, this is 30 times 8. So 3 times 8 is 24. So boom, I put the 4 there. And I put the 2 up here. 3 times 7 is 21. Add that 2 and I get 23. I still add these down here, these partial products. So 4 plus 0 is 4. 2 plus 4 is 6. 6 plus 3 is 9. And 0 plus 2 is 2. But remember, we said I have to have 2 digits to the right of the decimal place in my product. So boom, 29 and 64 hundredths. I can do the same thing over here if I multiply these, right? 8 times 8 is 64. Boom. 8 times 7. I won't go through the entire thing, but it's the same process. The only difference is I just removed the decimal, okay? So you can do this process over here with the decimal, but I want you all to see how it's the same exact process. The only difference is we have to make sure that we put our decimal back into our product. All right? Let's do one more example and then we'll be out of here. So example 3. Let's say if I had 26 hundredths and I want to multiply that by 34. All right. Same thing. Notice I have 2 digits to the right of my decimal in my factors. So once again, 2 digits. Okay. In my product, right? So I can multiply this as if I'm doing 26 times 34. I'm gonna stay on this side this time. So 4 times 6 is 24. I'll put my 4 here, put my 2 up there. 4 times 2 is 8 plus 2, which is 10. So I have 0, and I can put this 1 up there. 4 times 0, 0 plus 1 is 1, okay? Have to have that 0 placeholder. And now I'm going 3 times 6, which is 18. So put my 8 there, cross out that 2 and put a 1 here. 3 times 2 is 6, plus that 1 is 7. And 3 times 0 is 0. We don't have to worry about that one anymore. So 4, 8, plus 0 plus 8 is 8. 4 plus 0 is 4. 1 plus 7 is 8. But remember, I have to have 2 digits to the right of the decimal. So I put my decimal right there, and 8 and 8400ths will be my product. All right, so few things you want to remember when you are multiplying decimals. You want to make sure that if they are more friendly numbers, you can simply, like a whole number times a decimal to the 10th place, you can simply take those digits. So if I had 5 times 2/10, then 5 times 2 is 10. But because it's 2/10 that we're multiplying that 5 by, I need to have one digit to the right of the decimal. So 5 times 2/10 is actually 5 times 2 is 10, so it's 1.0, 1.0, or 1 and 0 tenths, however you want to say it. The language is very, very important. The other thing you want to know is whenever you are multiplying larger numbers, when you have 3 digits, 2 digits, however many digits, for whatever grade level you're in, you multiply just as if you're doing the standard algorithm for multi-digit multiplication. And then when you get your product, when you get those final digits, you want to make sure that you look back in your factors, and however many digits are to the right of the decimal place in your factors, that's how many digits are going to be to the right of the decimal place in your product. Do me a great big favor, like, share, and subscribe to my channel, Young Gurus Math Tutoring. Share this with your teacher friends, share this with your student friends, and thank you so much for checking in. Those of you that are watching the replay, please do me a favor, like, share, and subscribe as well. I hope this helps somebody out there. Thank you so much. And remember, Young Gurus Math Tutoring, I've got the solution to your math problems. Peace.